so we're continuing on. This is going to be, we'll call this 6.1b, so just in case you're unsure. I don't know if I changed the title on your notes if you are in my class, but we'll get there. So 6.1b, so second video. We got to finish this problem up. We basically just want to find the area of that region. We have a lot of the information that we need right now. I guess I have the red. If you look there, you kind of have the red is this. And you have the blue equation is this. So which one's top? Red is on the top. Oh, sorry, this should actually be green. Red is on the top, or green is on the top. Well, red is on the top. So it's going to be the integral from where? Where do we start? Well, we look at those limits of integration. They're called limits of integration. And that's going to be the area from -2 to 1. Those are on my boundaries, right? And they're not vertical lines now. They're actually like points because the graphs intersect. So this is a more common situation. If they say between x and whatever, you got to close it with those lines. But in this case, they're both meeting in an interesting way. The area between there has to be positive because like area as a whole is positive, but area under the curve, we assign a negative to it. So what I want you to understand is that this is all positive of an area. Okay. So maybe I can help you to understand that a little bit better just before I confuse some people. If I was to draw this graph, and I was to say, what is the area between those two graphs? So what is the area in here, this? Look at how much of that is below the x-axis, most of it. Look at how much is above. You would think it might be a negative area, but that area is positive because it's the area between two curves. So keep that in mind as you're going through these problems. Okay, sorry, I got a little distracted with that. We're going to take the first function, top, minus the bottom function, and we are going to simply integrate that. So all you need to do is now solve this problem so you can forget about everything else. You can just kind of just go at your own pace and solve it. I would encourage you to pause the video and try to integrate that if you're able to. And if not, I'm going to do it in just one moment. Okay, so as I integrate, I drop the integration symbol and I get to this point of this. Kind of looks familiar to what we had before. And our integration, now that I've integrated, only now that I've integrated, I change this to a -2 and a 1. And now I'm plugging in numbers. So let's plug in some of those numbers. Let's plug the top in. Fundamental theorem of calculus, this is called. 2 minus 1/3 minus 1/2. Hopefully I haven't made that mistake again. Minus, now I got to plug in the -2. So I have -4. I have negative 8 over 3. I have -4 over 2. So that wasn't ideal, but we can at least change those to positives. So just trying to simplify this up. Let me change the color so you can see what's going on. 2 minus 2 over 6 minus 3 over 6. So I guess minus 5/6. So that's 1 1/6 for now. So that's that. Minus. Now let's go here. Okay, so let's make it -4. I'm just going to keep the parentheses for now. -4. I'll make this over 6, so plus over 6. 16 over 6 minus 12 over 6. So that's going to be 4 over 6. -4 plus 4 over 6. -3 and 2/6. So that's going to be -3 and 2/6, which is going to finally translate out to positive, because we're going to negative 3 1/3. Okay, so we add those together. We got 4 and 2/6 plus 1/3. Oh, sorry, oops. That's a little backwards, isn't it? 4 and 1/6 plus 2/6, right? So 1/6 plus 2/6 is 3/6, I believe. 2, 3/6, so that is 1/2. So 4 1/2 should finally be our answer for that problem. 4 1/2 is what we're looking for. Or 9 over 2. So that's what the book has. Okay, so we've got to continue on. Make sure you're trying this one. I want you to sketch the graphs and find the area bounded between the two of them, okay? I'm not going to write, but I'm going to talk a little bit about this. You need to know where those graphs are intersecting because you don't have any x-axis boundaries now. So you need to get a good sketch, take your time, make a table if you have to, whatever you got to do. This problem is very important. I really got to be honest with you. This is an important problem to solve. I don't know if it works out easy, if the functions are great, but this concept is really important. So I'm going to try to highlight that today. So pause the video and give this a shot. All right, so hopefully that went well. You can check your answer in the back of the book for that, so that's a good thing. So on to example 3, and really we have 2 more examples. Would love if we could get these in. I think we're going to get it. I think we're going to make it happen. So we have the sine and the cosine graphs, and I have drawn the basic sine and cosine graphs. You should know that sine of 0 is 0 and sine of pi is 0, so plot those, and then try to make your graph based off of it. Just understand that like the sine starts at 0 and goes up, the cosine starts at 1 and goes down, if you're talking about the y-axis. Anyways, all of these graphs keep intersecting and making this like, I don't know what you want to call that, but like wave-shaped thing there, that like, I don't know, seal-shaped, blue-shaded thing. They want you to find the area of one of those regions, right? So what I'm thinking is, can we use a calculator, right? That would be nice to know. So give me a second to think this over, whether we should do this analytically or with a graphing calculator, and then we'll go from there. Okay, so after some thought, basically what you need to do is you need to set, right? You need to set sine of x equal the cosine of x. So that would be the red graph equal to the black graph, right? Well, when do sine and cosine have the same value? Think of your trig values. Sine of blah equals cosine of blah. We need that same thing to be the same, right? So sine of what equals what? Well, look back at your graph. I've kind of given you a pretty good hint. Sine of pi over 4, right? So sine of pi over 4, because you have 1, 1, root 2. So sine of pi over 4, that's a theta, is going to equal sine of cosine of pi over 4. So they're going to intersect at pi over 4 and 5 pi over 4. So at that point, we're in pretty good shape, because now we have pi over 4 to 5 pi over 4. Whoops, not great. 5 pi over 4. Okay, that's, you can maybe write it better than me. I'll try it again. Sine pi over 4 to 5 pi over 4. And now we have sine of x minus cosine of x. So sine of x minus cosine of x dx, don't forget that. And we need to just simply solve this problem now, which is pretty decent. We're in pretty good shape. I want to take a second to think about this, because derivatives and antiderivatives of sine and cosine have sometimes caused my students some problems. So I guess we maybe need to know what y, if y is sine of x, y prime is equal to cosine of x. And if y is cosine of x, then y prime is equal to negative sine of x. So the question is, when we're here looking at our problem, and I'll underline it in purple, let's say, try to go with a different color. When we're looking at this, right, this is the derivative, we want to antiderive it. So are we looking at situation 1 or situation 2 to antiderive? Well, we can't be antideriving situation 1 because the derivative is cosine and we are trying to antiderive, right? We're trying to undo the derivative of sine, so we need to go to where this is. So sine came from a cosine, but a cosine would give you a negative sine, so it must have been a negative cosine of x that came from. So that's what that goes to. Okay, moving on. Let's do some, I don't know, some strange burnt orange color. So now we have to ask ourselves for this one, right? Ugh, terrible looking. Negative cosine. Well, where did the cosine is the derivative of what? That's the question. And that means we're looking at this. And that means negative cosine must have been the derivative of negative sine. So this is negative sine of x. Okay, and now we're just integrating that from 5 pi over 4 to pi over 4. I'm going to fly through this, but don't forget these things. Okay, so negative cosine of 5 pi over 4 minus sine of 5 pi over 4 minus, and then we need to minus the whole entire thing, negative cosine of 5 pi over 4 minus sine, I'm going to change plus, 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 look at that, minus sine of 5, this is just pi over 4, dang, this is pi over 4, and this is pi over 4, okay? Okay, something that you should be able to do, so please go through and figure out those trig values. If you don't know them, go ahead and look them up, but I want you to save a little bit of time. You find that answer, and you had better have it on your notes. Look it up if you have to, put it into a calculator. I would prefer you didn't, but you need to be brushed up on those trig values. Okay, we're doing all right on time, not great, but we're getting there. So this is going to be the last thing we're going to need to do. It's basically just one more extension. You're going to have curves that can intersect at more than one point. So you really just need to know, what is this point? I don't know. What is this point? I don't know. And what is this point? Because we want to find the area in between. We want to find this area right here. We're looking for this and this. And now we have two different areas we're dealing with. So we need to figure out all these intersection points, and we should be in pretty good shape from there. Okay. Highlighter doesn't erase too well, but you get the idea of what we're trying to find. Okay, so how are we going to find them? Well, first of all, this is f of x. So this is the cubic. So I guess this guy is f of x. Okay. And then we got g of x, which is the quadratic. So I guess this guy seemingly would be g of x. So let's look at each region separately. If it's okay, maybe we should even consider doing it as two separate problems. So we could call this the green section, I guess. I was going to make it blue. It comes out green because of the combination of the colors. So why don't we just work on yellow first? So we'll just work on yellow, and then we'll work on green. And this is our first time doing it, so we'll just do it this way for now. Okay? Hopefully those even show up, but we'll see. So if we're working on yellow, what is the top function? In the yellow region, the top function is this guy right here, 3x squared minus x squared minus 10x. And the bottom function, I'm running out of space. I'm going to split the screen. So we've got that. Okay, make that a little smaller. Oops. Okay, yellow and green. Okay, so we got to subtract out from that minus this function. Well, it's negative x squared, so I'll make that positive, and it's positive 2x, so make that negative, and there's a dx. So that's how that integral is set up. And then this next integral is actually set up differently. So this is problem 2, basically. So we get two problems going on here. And that next integral, well, we have to have the red on the top. So the red is negative x squared plus 2x. And now we have to subtract out the top of this thing. Well, if we're going to do that, we might as well change all the signs. So we have minus 3x squared. We have plus x squared. Oh, this is cubed. Plus x squared, and we have plus 10x dx. So that should make sense, hopefully. You're doing top minus bottom for each individual section. Last but not least, we need to get these intersection points. So talking about the intersection points, this guy, and this guy, right? Well, how do we do it? Simply set f of x, which is this, equal to g of x. That's really all you should have to do. So let's kind of start going with that. So I'm going to try to start solving that. So I'm going to get rid of some of this stuff and just try to start solving. So I've got 3x cubed And this is just going to cancel out. And then I'm going to minus that, so I'm going to have minus 12x equals 0. So if I take out a 3x, I have x squared minus 4 equals 0. So I have x equals 0, x equals 2, x equals negative 2. These are my limits. These are the things that I need to have on those integrals. So I just need to simply take these over there, okay, and start thinking about what goes where. So let's go back to our graph and take a quick look at what we got. So I guess this first integral is from negative 2 to 0. So this is from negative 2 to 0. And then the second integral is from 0. And where does this integral end? Well, it starts at 0 and it ends at 2. And that's how we're going to set our integrals up. So in the interest of time, I'm not going to finish this. I'm going to have you finish this problem so that you don't have to watch any more of this video.